All right, hello. It's been a while since I made my last video. So today I want to just discuss the concept of AGI or artificial general intelligence and what I think it means, at least in the context of a household. So imagine the case where you have access to a technology that can practically do anything for you uh, on the internet, control any kinds of electronics, and be able to speak with you or interact with you similar to how you would interact with a human. Does that qualify for artificial general intelligence? What are the different components that would go into something like that, and how can we build them out with what we have today? I think this is just more so a mental experiment from my end, because I am so invested in this technology from like an interest standpoint. I'd like to understand what we're talking about when we say artificial general intelligence, because it seems like a term that, at least in the few years that I've cared about this topic, people have thrown out a lot, and the understanding of it has shifted dramatically, like year by year. So I'm just going to jump around. Hopefully, this makes sense as we go along. So, assuming we have an application that allows you to connect to the um, some form of LLM or multiple forms of LLMs, and each one of them has its own set of skills that defines how expensive it is to host it, inference it, and use it. Now, I'm giving out this example specifically because when we think of what an artificial general intelligence can do, based on what we've seen in videos and movies, media in general, they tend to have control over some form of robotic body. They tend to be able to intelligently understand what's going on in the outside world and how that relates to you specifically. They tend to be assistants, so you can think of Jarvis and all of these other types of um, applications. So we need some form of intelligence underlying this system, but it's not the only thing um, that is necessary for this to work. So when we talk about that intelligence, what exactly are we saying? An LLM is one form of intelligence. There's many different forms. So you can have bots that you write from scratch that are meant to do some like specific set of actions. Let's see here. Trading bots. So a trading bot is a form of intelligence. Now, whether or not this is something that can react to the outside world doesn't matter as much, but it is some form of intelligence that's been condensed into a process that we can run that has access to external systems like, let's say, wallets and all this other stuff. And it can make decisions within a narrow range, maybe, or a narrow subset of total possible decisions. It could decide to do this thing or the other. So a trading bot doesn't typically have an LLM attached to it. It's just a system that you write targeting some form of, let's say, like a form of opportunity that is available on a market. You can think swapping from USDC to ETH or USDC to Bitcoin or gold to silver, whatever it is. All right, so from there, now we know essentially what intelligence means. You can have written scripted intelligence, and you can have LLMs, which tend to be more random. By random, they have a wider range. They could react to their environment in some shape or form that could allow you to accomplish some goals. So we can think of GLM as an excellent open weight example that we have access to. It is an extremely intelligent coding model. It is good at security. It is good at all sorts of agentic use cases. So you can take that or some smaller version of this if you're running it at home, and now you have your intelligence. Now, each intelligence has some form of limitation assigned to it. So some of them have 200,000 K context window. They don't have the ability to do vision, so this is GLM. Some of them have longer context windows, but they tend to fall apart after like 64,000 tokens. Some of them are fast, some of them are slow. So each form of intelligence is a compression of a bunch of information that is on the internet. Taking GLM, so the lab behind it, ZAI, has access to a large data set, both stuff that is publicly available, you could just find it on Hugging Face, and maybe stuff that's proprietary. That is then trained into the model based on the architecture of the model. So some models can be like super wide, some models can be a mixture of experts. Each one has basically downsides and like advantages based on how it's architected. But that information that we're talking about, like all of this coding knowledge, it gets condensed into the weights that we have provided the model at the start, and eventually it gets trained and it knows how to do things. Now we have our intelligence. The next step is hosting it. So hosting it, right now you have a few options. You have things like VLLM, which I think right now is the most approachable as well as the highest performing. It's got a really good mix of things. It's open source software. It has great support. It's fast. It usually has day one support in general. And so you see you can run it on ROCm. And like these are all different architectures for computers. Macs, let's say, and the Ryzen AMD chips or NVIDIA GPUs. And it allows you to host or run the model weights. So the model weights, if we go back into Hugging Face, you can see here the model weights are 1.5 terabytes. That is huge. That is very, very big. And you need to add on like 10% for what are called activations. So this is like, there are extra costs for VRAM that make the model for a single person, if you're trying to host it, I think this would end up being like 1.75 terabytes. If we try to host that on GPUs, we would need either a whole bunch of small GPUs or like a fair amount of large GPUs that are super expensive. So the cost is unmanageable for the majority of people. Self-hosting a model of this size and this intelligence is unlikely to happen unless you are either doing compression tricks, which are something that is gaining in popularity within the AI ecosystem. So I like a method called REAP. I also like quantizing with autoround. This is Intel's algorithm. It lets you find, basically it just provides compressions that are pretty high quality. I might leave the paper in the description. So that will let you shave off like 85% of the VRAM requirements, but that's still like 400, 500 gigabytes. And for most people, that is unapproachable. But there are companies that are making LLMs that are highly performant, that are very small. This is an example here, Gemma 4, it's made by Google. From my understanding, and I don't really know whether or not this is true, they have their large models and they distill them down into these smaller models. It could be possible that they're pruning them. It could be, I have no clue what exactly they're doing to get these weights, but it is open source. It is Apache license. So this is a very nice thing that they've done. And you can see here that it's 62 gigabytes. Now, this is a much more approachable cost for most people. This means you would be paying somewhere between $2,000 and $10,000 to host something like this. But if you add quantization to the mix, you can shave off 75% of the costs, and you might be able to pay $1,000 to host a model like this. This one will be pretty slow because it is a dense model. So intelligence in the LLM world comes in dense and MOE. Like these are the two main standards right now. I'm sure there are others, but these are the dominant options that we have. A dense model will activate all of the parameters that you see here. So when it says 31B, that means 31 billion parameters. And you can imagine parameters as 16-bit numbers. So you have 31 billion 16-bit numbers, and each one has like a specific weight, and you end up basically for the parameters, if it's 31 billion, If you have it in full precision, which means FP16, and you have 16 bits for each parameter, it's going to take 62 gigabytes, right? Double the gigabytes. If you have it in 4 bits, you relatively lose little, but you can get it like much cheaper and much more compact. Once you get to that point, you can host this model on much smaller hardware, and you can start using it in things like Hermes agent, which I'm going to show in a second, because I'm not sure if this is going to be secure. Hopefully it will. We have Hermes agent right here, and you can see that I have my Hermes, which is a bot on Discord, and I have the different channels that I have conversations with it. I'm not going to go into the different channels, but right now I'm researching, or like I'm playing around with Ghidra. I'm not researching it. Ghidra, or I'm not really sure how you pronounce it, but it is a repo for reverse engineering other code, and it's just super interesting to see what models can actually run this software, how good they would be at it, etc. So that's one of the things that I'm trying to do, but this is using local models in the background to do the kind of work that we're talking about, which is providing the intelligence. I'm going to show one more thing before we move on from this point. We have the Gemma model that is a mixture of experts. So this one is a little bit smaller than the dense model, and it only activates a very specific, it's a specific percentage of the model that gets activated per token. So what that means is you can have a model that, let's say, has access to 5 different data sets. Imagine it that way. It has access to a lot of different combinations of data, and only a certain percentage of it lights up based on what you are inputting. The model has a router. The router decides, well, these different experts should respond to this specific prompt. What this does is it reduces the amount of parameters required to generate a token. So the active parameters. With the 31B model, when you run it, all 31 billion parameters are active, and it's very slow because it has to do whatever amount of math on 31 billion parameters. With this one, it's a little bit smaller, and only 4 billion parameters are active. So it should technically be about 8 times faster, give or take. Maybe a little less. Yeah, anyway, that means that it's going to be significantly faster because only a small percentage of those experts need to be activated, which lets you use mixed memory. So mixed memory is AMD. The framework desktop has mixed memory. MacBooks have mixed memory. So that is where the GPU or iGPU and the CPU are essentially part of the same chip, and you are then able to have like a larger amount of RAM capacity, but less acceleration parallelism. As with NVIDIA lets you have maximal parallelism, and the actual chip is a GPU, so it is it just has way more, like it's able to do way more math much quicker than mixed memory. Think of it like that. One is cheaper, you get access to more memory. The other one is more expensive, and the memory is much, much faster. You also have the option of the cloud. So cloud is, you have, whether it be an open lab or a closed lab, they are able to provide you with the intelligence. A great example is OpenRouter. So let's go and check OpenRouter out. So OpenRouter, as you can see, is a website here. It shows how many monthly tokens are being used. It's 70 trillion. That is an insane amount of demand. There's 5 million global users. Anyway, when you click on models, you have all of these different LLMs. Remember, each LLM is a compression of a lab's data, public and private. It is taught to do fancy things like use a computer, use a browser, but at the end of the day, it is a compression of data that is found both publicly and privately. Part of that data teaches it how to behave in specific ways, like be an assistant. And for this, to understand this, I would like to refer you to Andre Karpathy's or Karpathy, not sure which pronunciation it is, but I would recommend his videos. He goes into the details in terms of like how all of this stuff works on a lower level. I am just trying to make it more clear on that higher level what is going on. So now we have a website like OpenRouter. It lets labs and data centers service model weights that they can get, for example, off of Hugging Face. You see, you can just click here and you can download it or deploy it directly. So they can just take this here, launch it on their GPUs, on their servers, whatever it is, and make the public pay for it, right, to use it. They can go to OpenRouter or other websites that allow you to do that. Each model has its own like positives, pros, and cons. So the Claude model is known to be a very good coding model. It is good with vision. It's fun to talk to. GLM is also like a very good coding model. It's very good at agentic. It's from a Chinese company called ZAI. There are other ones like Google's Gemma. So this is an open weight model that they released publicly, and you can even access it for free. That's another thing that's important here, is you have access to free intelligence that you can just hook into and test and like use to build whatever it is that you want, because it's just there, it's available, and it's free. Given that different models have different levels of intelligence and different things that they're good at, we can take a model like Qwen 3.5. Let's go to see, it's right here. We can take this one, Qwen 3.5 REAP, which is a form of compression, 262B, so that's 262 billion parameters, and it has 17 billion active parameters. And then this here is a quantization code, so W4A16. That means that the weights are 4 bits and the activations are 16 bits. What I mean by activations is during the quantization process, you take a data set and you give it to a model. The model then views this data set, and you can see what experts and what weights are activating and how much they influence the final decision. Based on that information, you are able to determine what weights matter for whatever data sets you want to specialize in. This is a model specialized for agentic behavior, and I am hosting it on 83090s, but I could also host it on a Mac Ultra or on like maybe 2 framework desktops, or even less, because there's smaller ones. For example, here, GLM 4.7 Flash 8-bit. This is a 30 billion parameter model, and it's in 8 bits, so that means it is 30 gigabytes. Most people have, most people who work in this industry have MacBooks that are around 32 to 64 and sometimes more gigabytes. So you can further quantize it, and you can have this model running on your laptop doing work for you. When I say doing work for you, I think it's very important that we understand what that means and how that would help you in your life. Because a very common thing that I get a lot of the time when having conversations about artificial general intelligence and even just artificial intelligence, it is, well, what can you do with this? Is this going to make money? The problem is that money is not relevant in this conversation. This is a form of intelligence that could be harnessed to do things that are economically viable, as well as things that are not economically viable. We could do both. Now, I'm opening this video here. This is my desktop on the left. You could see it with all of the different files in it. It's a mess. I really just go through periods where I just like let it go to shit, and then I will run a video or take a few minutes to reorganize it. So before we go on with this video, you can see again my desktop is a mess, and you can see here that Qwen 3.5 262B at home lab. So if we went back over here, let's try to get this back. You could see here, this is Qwen 3.5 262B, and that's essentially what I am servicing. It's right here. This is a video recording, but we'll do it live as well. So I was running this model and I wanted it to clean my desktop. So this was a video that Anthropic made sometime like a few months ago, maybe 3 months ago, with their Claude desktop app, and I thought it was impressive. I mean, it is impressive for sure, but what I'm trying to say now is that this capability to do this is like really not expensive, right? You can have your own laptop, your own computer, and you can run this software on it, and you can see here, like these are good speeds. I mean, I think I just 2x'd, but it's still going at least 30 tokens a second for generation and a few thousand tokens a second for prefill. So you can see here, it's running the agentic loop. It's moving files into different directories that are labeled. Now, this model here is a vision model. It is a good agent, and it is decent at coding, right? It's not great, but it's decent at coding, so it can do things for you, especially if you want it in the form of a home assistant or just like an assistant in general, right? That is on your own technical infrastructure. So we have it open right here. I'm going to select the model 262B, and I'm going to ask it to build me a some form of game. This is important here. So you can see that thing that popped up. This is a text-to-speech or speech-to-text software. I have a hotkey on my computer. I click Control Option, and then this pops up. Anyway, what we're trying to do is use this empty directory to build a 3D video game using 3JS with no other dependencies. This game must allow us to fight. Let's make it a first-person shooter. It should be 3D. There should be lighting and reflections. You need to test the gameplay. There should be enemies that try to chase after you, and just figure out like how it's supposed to look, and then test it. Don't say you're done until you've tested it and you've confirmed that this is working and all of the behaviors that you are intending have shown up. And here now it is taking my speech and it is dropping. So let's give it this. What's going on here? That's strange. Whatever, let's just do that. All right. So I have sent a request to Quen, and you can see here that my GPUs are at 100% utilization now. Each GPU has 24 gigabytes of VRAM, so this is video memory, and each one has 22 gigabytes that are in use. Total memory used is 175 gigabytes. It has 200K context, and it is relatively fast. I mean, I can benchmark it. I'll just queue in a benchmark to see how fast it'll go. Unfortunately, yeah, this is my own thing, so it breaks all the time. However, we could see it here. It's already working, right? So we have the text-to-speech or like speech-to-text stuff on this device as well. I am trying to find where it is. So you can see LM Studios open, and then I have Super Whisper. That's the hotkey. So with Super Whisper, I can just say what I want. The machine takes the audio, turns it into text using a model called NVIDIA Parakeet. And this will then put the text in my clipboard so I can paste it, and the model will then just figure out what to do. So now I'm running the model. I'm running it in Droid. And I use Droid because it tends to keep these like smaller models or less intelligent models more like, I don't know, performant, which is very useful because it's really hard to harness intelligence that is lesser and give it like larger tasks. It tends not to work really well, so Droid is really good at this. I think there was also root code that did this well. Open code is decent. I mean, it has a lot of like connections. It makes things very easy to connect to. Pi is, I think, like better with these larger models from my understanding and my usage of it. So there are all these different harnesses is the point that I'm trying to get to. And the harness itself is really important in terms of the actual performance you are going to get out of an LLM. A harness is just a set of tools an instruction manual and like a connector, essentially. You essentially do whatever it is that you prompted it to do. The harness helps it get there. So now when we connect all of these different pieces together, we take the harness itself, we program it to allow it access to Figma, or as you can see in the back, a 3D printer, or a house network. That's step one, right? You're giving it access to your personal infrastructure. Now, step two is, can this model effectively, with the right instructions, use these tools that it's been given to help you in your life in some form or another, whether that be software engineering or robotics or learning a language or doing your groceries? Can it do that with the right set of instructions? The answer is almost all of the LLMs on the market today can do this, whether they're open weight or closed weight. They just need more or less direction, and they take more or less time to get there, and the cost of the model ultimately dictates a lot of what is going to happen. So we have all of these different pieces, and we put them together in a home or a business. We give them access to our emails, our financial statements, our applications, GitHub repo, messages, desktop computers, GPUs, and we prompt them with English within a functional harness that is able to take them where they need to go. From there, you can see it is able to use a browser. It's taking screenshots. It's playing the game, actually. It's awaiting the game to load. It's trying to get a screenshot. It's using the, what's it called? Like, here you go. Yeah, so I click, nothing happens. I'm not going to tell it that anything is happening. I'm just going to let it run its course. But the gap here, and the reason I'm doing this video, I know it's been like very rambly, but the reason I am doing this video is there is an effort that is being made to make people feel like this is something that is complicated, or this is something that we do not understand. It is pretty simple. All of the different pieces are reproducible. It doesn't cost that much to reproduce it. Models from as small as 9 billion parameters or whatever could run on a phone to as large as like 5 trillion parameters are on Hugging Face, or at least within labs. There are dozens of flavors of open weight models, whether that be video generation, text generation, audio, coding, agentic workflows. Quen, which is Omni, it does all this shit. It can watch videos, it can look at images, it can listen to audio, it can control a browser, it can do literally anything, right? So this means, and we can also check here, I feel like this is wrong. I don't think I ever did this, but that's fine. Let's do Quen 3. Home. Yeah, I think this is just the wrong one. Anyway, we're going to find the home, and we're going to see custom, Quen 3.5, 262B. Find me OXero's GitHub, just as an example. I think this is an outdated version of the app. I might need to go reinstall it. But anyway, this is also connecting to my backend here. You can see it here. My GPUs are at full utilization. One drops, the next start. One drops, the next start. It's using both Droid and this here at the same time, which is very useful. Sometimes it's going to fail, but you can see that it just kind of keeps pushing on, keeps moving forward. And I think that that's super important. So I found my GitHub, all that. Find me a GPU. Let's see. Find me a place to rent GPUs. Let's say I don't know anything about this, right? It can essentially do anything for me. I can tell it to pay my taxes. I can tell it to go and write my posts. I'm not going to do that, but I could. So this is, in my opinion, AGI. We don't have the right infrastructure to make it feel for the average person as if it was intelligent. The average person will turn on the Codex app or Claude Code or whatever it is, and they will try to use it, and there is a barrier in front of them. And that barrier is their understanding of being able to keep moving forward without anybody telling them what to do. These models are vastly intelligent within their context window, or at least the first half of it, and can practically do anything, right? That is digital. They can control weaponry. They can investigate people over the internet. They have been able to hack things for the last year. They listen to instructions. They are essentially programmed to be assistants. So you can't say something wrong to it. You can just install it and make it do whatever you wanted it to do. And this is a big change that is hitting the world, that is already like over that line. It's just going to take people a lot of time to deconstruct the idea that, our jobs are unique and special, that the economy is real or not real, whatever it is that we want to say, that a robot can typically do most of their job better than they ever could, or at least more of their job than they ever could, and that you can ask for anything and you shall receive. I think this is very important for us to understand innately, to learn about, to teach the people around us, because it doesn't apply just to building websites or creating content. It is going to change how we do a lot of business, whether you like it or not. The total cost of using AI is lesser than the cost it would take to use people. And wherever that's true, we're going to have AI be slowly embedded in there, and the people slowly exported out of there. And that's natural. That's happened with a lot of technology. But our definitions of what AGI is or how we can expect it to be is limited by the infrastructure that we have, not necessarily the intelligence and the agents and the pieces that you have to put together. It is already here. It's just in a state that is very, I don't know how to say it, brittle. It's brittle. It's artificial general intelligence for 30 minutes, not for weeks at a time. Let's try to end it with this. Let's see if this is going to work. I don't think it will. Yeah, it doesn't seem to work, but it is adding in. Let's go back to the code base. The start button doesn't do anything, but I'll just let it. I'm just trying to demonstrate the agentic loop. Let's see if this is going to start to show you. Okay. Let's see. So you can't really start the game, but perfect. Let me close the browser and provide this. Well, you can't play the game. Let's see. As you can see, though, it did make progress, right? I could see the map in the back. Okay. We have it all. Just the point here is that, we are way into a big change in how we're supposed to work and what we're supposed to be doing with our time and life. And we have to absorb it and understand the implications of it on our businesses, our neighborhoods, our families. We have to teach other people what is going on. And hopefully we have to just know that this is not magic, and it is very fun, very cool. It's worth getting into. Hopefully this video is helpful. Thank you for listening.